All right, looking at our next example, we are going to integrate 1 over x times the ln of x. So you have to be careful here because we don't have a product rule in integrating. Remember, we only have a product rule in taking the derivative. So the first thing that we need to do is break this apart. We're going to break apart this integral into what they're multiplied by. So we can break apart those two fractions. We can say it's 1 over x times 1 over the ln of x dx. Okay? Now we can use u substitution. And in this case, we usually use the function that has a higher power, but in this case, we don't have a higher power. We just have different functions. So we're going to take the more complicated function, which in this case is the ln of x. So we're going to set u equal to the ln of x. And we'll take the derivative of that. So we'll have du equals the derivative of the ln of x is 1 over x dx. So once we get this, we take it and we substitute it back in. So we have, we will turn this 1 over the ln of x will become 1 over u. And du comes from 1 over x times dx. So that's 1 over x times dx will turn into du. Okay, so everything has worked out perfectly. When we use u substitution in these cases, they're going to give you problems where this works out. Okay, so we don't have 1 over x. We're all left with 1 over u du. So the next step to do is to integrate. When we integrate 1 over u du, we get the ln of the absolute value of u. This is an indefinite integral, so we have plus c. Then we just have to put our u's back in. So u is the ln of x. So what's in here, this u will turn into the ln of x. So we put back in what we substituted, and we have the ln of the absolute value of the ln of x plus c. And that's our answer for this problem. Yes, we have an ln and an ln. Yes, they go together. Yes, it's double. It's fine. That's our answer to this problem. All right, let's look at the next one. Now we are going to integrate 1 over the square root of x plus 1. Okay, look at that square root. The square root is only on the x. It's not all the way over. So we can't just say u is x plus 1. Okay, so when we have this situation, when we have the square root of x, what's going to happen, and what's a little bit different than we've done before, is that we're just going to set u equal to the square root of x. Now, usually we go ahead and take du, but think about it. If we take du, we're going to end up with 1/2 in front and negative 1/2 up there. That does not help us in this problem, okay? So what we need to do is actually get rid of that square root, because the square root is what's tripping us up. So to get rid of the square root, we square both sides, and we get u squared equals x, because u squared is u squared. Square root of x squared, they cancel out, and we just get x. Now we take the derivative. So we are going to square it first to get rid of the square root. Okay, we can do that as long as we do the same thing to both sides. We can get rid of what is tripping us up. When we take the derivative, we would get 2 du over here, because u squared, the 2 comes in front, and then we have u, and then du. The derivative of x is just dx. And this is what we're going to use to substitute everything back in. So this square root of x becomes u, and dx turns into 2 du. So we have our integral. We have the 1 that stayed on top, the plus 1 that came from up there. Square root of x turns into u, and dx right here, from right here, turns into 2u du. Okay. So now I'm going to take this 2 and put it out front so that we have this. And what we need to do, again, a couple examples ago, we divided to break it apart. So we need to divide these two because they have the same power. See how we have u to the first over u to the first? Those have the same degree. Whenever we have the same degree, we have to use polynomial division to break them up. So the one on top, u, is being divided by the one on the bottom, which is u plus 1. So with polynomial division, what we do is we look at the first variable, usually it's a variable, and we decide what times u would give us a u. Well, those are exactly the same. So u times 1 would give us u. And then we distribute the 1 back out. So we have 1 times u is u. 1 times 1 is 1, so we have plus 1. And then our process in long division, the next step, is subtracting. So both of those are subtracting, so the u's cancel, and then we get minus 1. So this is minus 1 over, our remainder is over what we divided by, and we divided by u plus 1. Okay, so we put that back in here, so we have a 2 out front of our integral, and we take what we divided, what we got, 1 minus 1 over u du. Now we break this apart into two different integrals. So we're going to have 2 times, both of them get a 2, so be careful there when we split this apart. 2 times the integral of 1 du minus 2 times the integral of 1 over u plus 1 du. Everything here can be integrated. We can integrate 1, we can integrate 1 over u plus 1, okay? When we integrate, we'll get u, 2 times u, minus 2 times, this is an ln, u plus 1 will be inside the absolute value. And then we have plus c. So we've integrated, and the last thing to do is here we have an answer with u's in it, and we need to substitute the square root of x back in for u. So in the front, 2 times u becomes 2 times the square root of x, minus the ln, u becomes the square root of x, so we have the square root of x plus 1. Make sure that your square root is not over that 1, it stops just on the x. Make sure you have your absolute value bars, and then plus c. And that's our answer to this problem.